Alright, my peoples, so we're going to work on Unit 3, Worksheet 3, problem number 8. So, in this problem, Amanda drops a rock from a height of 35 meters. While falling, it has an acceleration of -10 until it lands on a puppy. What's the speed of the rock when it hits said puppy? So, we're going to start here with a diagram. And my diagram's going to have a nice... So, I got my axis for my diagram, and we will have our graph line drop from rest, falling down, so we'll have negative velocities. We'll name our axis. This will be v in meters per second, and this will be t in seconds. So there we have a little diagram for ourselves. We don't know how long it takes for it to fall down. If you wanted to do a different type of graph, that's fine too, or illustrated diagram. So knowns and unknowns. We know that the initial position of this rock is 35 meters above the ground. We also know that it's falling to the ground, and that means that its final position is 0 meters, which means that its change in position, or its delta x, its displacement, would be final of 0 minus initial of 35, and that's a change of -35 meters. So that is known. It's also known that the acceleration while this rock falls is going to be -10 meters per second squared. What we don't know is v final. And while it's not stated, we do know the initial velocity because this rock is dropped from rest. So that means that when she drops it, it's not moving. So there I have my known and unknown values. So down here, we'll get down to a variable form equation that will allow us to solve for speed. So I'm looking for something that has v final in it, and what you might start off thinking is v final equals v initial plus at. The problem with this equation is that we don't know time. No time is given for this, and so this equation, while it's not impossible to use, it's not super helpful to use. Going back, we have another equation for v final that doesn't involve time, and that is v final squared equals v initial squared plus 2a delta x, or the displacement. Plugging in and chugging from this point forward, we get v final squared equals 0 meters per second squared plus 2 times -10 meters per second squared times a displacement of -35 meters. And if we look at this, when we multiply our meters by our meters, we'll end up with units of meters squared per second squared. So simplifying this out, what we end up with is v final squared equals, let's see, 700 meters squared per second squared. Continuing on, take the square root of both sides, so v final equals the square root of 700 meters squared per second squared. And when we square root these units, meters squared square rooted will become meters, seconds squared square rooted will become seconds, and so we'll be left with an answer of, let's see, plus or minus 26.46 meters per second as our answer. Now, when you take the square root of a number, you get two answers, positive answer and a negative answer. For us, only one of those can be correct, and in this case, we can refer back to our diagram and see that our final velocity was in the negative direction. Therefore, only the negative answer here is correct, -26.46, and that's our solution.